Have you ever wondered where you really stand? In a class, in a competition, even in your salary bracket. We are constantly being ranked, but how does that ranking actually work? Well, today we're going to pull back the curtain on the powerful and, believe it or not, surprisingly simple stats that define our place in the world. Think about it. You get your exam results, you see your rank, and you wonder, how did they even decide that? Or maybe you see a scholarship that's only for students in the top 10%, and you're thinking, okay, but what does that actually mean? These aren't just random questions. They're answered by a very specific set of mathematical tools. And these tools, these measures of position, they are absolutely everywhere. We're talking university scholarships, your rank on standardized tests, even how a doctor tracks a baby's growth on those charts. They're used to compare salaries and even for critical medical diagnoses. I mean, these numbers have a huge impact on our lives. So, what's the secret? How does it all work? Well, it all starts with a pretty basic toolkit for just slicing up data. Let's dive in and look at the simple math behind these incredibly powerful rankings. First up, we've got quartiles, and the name kind of gives it away, right? Think quarter. All you do is line up all your data, say test scores, from the lowest to the highest. Then you just slice that whole list into 4 equal chunks. Each one of those chunks is a quartile. Simple as that. Okay, but what if you need to be a little more precise? Well, then you use deciles. You see that dec prefix? It just means 10. So you're doing the exact same thing, slicing the data, but this time you're making 10 equal parts. Each slice is a neat 10% of the whole group. And for the most detailed view, the one you've definitely heard of, we have percentiles. This is where you slice the data into 100 equal parts. So if you score in the 90th percentile, it means you did better than 90% of everyone else. See? Quartiles, deciles, percentiles, they're all just different ways of slicing the same pie. Now, I know what you might be thinking, here comes the scary math. But honestly, the basic calculation is super simple. You just arrange the scores, count them up, and plug that number into a really straightforward formula. This formula here, it doesn't even give you the answer. It just tells you the position, like where to look in your sorted list. It's just a few easy steps. But what happens when that formula spits out a weird number, like 8.25? I mean, you can't have the 8 and a quarter score in a list, right? This is what we call the in-between problem, and it happens all the time. It just means we need one more tool in our kit. And hey, this isn't just some abstract textbook issue. This is a real question from a Reddit user trying to figure this exact thing out. It's a super common point of confusion. What on earth do you do when your calculation doesn't land on a nice, clean, whole number? Well, the answer is a technique with a fancy name, linear interpolation. But all it really is a smart way to find the value in the middle. If your formula points to the 8th spot, awesome, you just grab the 8th value. But if it points to, say, the 8.8th position, you just find the value that's 80% of the way between your 8th and 9th scores. It's just a logical way to fill in the gaps. Okay, so that method works great for a classroom of 30 kids. But what happens when you're not dealing with 30 scores? What if you're dealing with billions of data points every single second? Yeah, the scale of the problem just changed completely. I want you to just look at this number, a trillion. We're talking about a data set with a trillion points. Think about every single click, every Netflix view, every transaction on Amazon. The scale is just, it's almost impossible to wrap your head around. So how on earth do you sort a list that big to find the 99th percentile? Well, here's the short answer. You don't. You can't. That simple sort and count method we just learned, it would be computationally impossible. It would literally break the most powerful computers. You need a completely different game plan. And this is where things get really, really cool. This is the frontier of the field, where researchers and engineers had to invent a much, much smarter way to summarize all that data without having to actually store every single piece of it. So let me introduce you to the T-digest. It's this incredibly clever algorithm built for this exact problem. Instead of trying to hold on to a trillion data points, it creates a tiny, super smart summary. Here's an analogy. Instead of trying to memorize every single grain of sand on a beach, you just remember the shape of the dunes. The T-Digest does that with data, and it lets you get unbelievably accurate quantile estimates. So how does it pull this off? The big idea is clustering. Instead of remembering every single number, the T-Digest is smart enough to group nearby values together. Each of these little groups, or clusters, is then represented by just two numbers, its average value and how many points are inside it. It's kind of like looking at a huge crowd and saying, okay, there's a group of about 50 people there and 100 over here. You get the whole picture without needing every single person's name. But here's the truly genius part of the T-Digest. It's most accurate at the tails, the very, very high and very, very low ends of the data. The clusters it makes at the extremes are smaller and way more precise. And that is absolutely crucial when you're trying to find outliers, like the 99.9th percentile of server response times. So you can catch a critical error before it takes down your entire system. And look, this isn't just some theory from a research paper. The T-Digest is already working hard under the hood at companies like Netflix and Microsoft. It's a key part of massive open source projects like Elasticsearch. They're all using it to monitor their gigantic systems in real time. It's proven, powerful, and incredibly efficient. So, wow. We've gone from a simple classroom ranking all the way to these wild algorithms that basically power the internet. But let's bring it all back home. Why does any of this, quartiles, T-digits, why does it actually matter? Because it's about so much more than just the numbers. There are some really important hidden learnings here. First, understanding how data gets interpreted is an essential critical thinking skill today. Because when these numbers are misunderstood, it can lead to evaluations that are just plain unfair. Using these tools the right way is fundamental to fairness and equity, and that comes with a real ethical responsibility. And you have to remember, the stakes here are incredibly high. These calculations, whether it's a simple quartile or a complex T-Digest, they determine who gets the scholarship, who receives competitive pay, who gets the right medical diagnosis. Suddenly, fairness isn't just some abstract concept. It's a calculation that has to be done right. Which leaves all of us with one last massive question. In a world that is more and more defined by data, the algorithms, and the people who build and use them, they hold an immense amount of power. So the question we really need to ask isn't just